Here's an overview of 4 simple gas laws that you should learn in order to understand how larger or more complex gas laws work. Let's start with Boyle's law. Boyle's law is the relationship between pressure and volume. So we have P comma V. The equation is P1 V1 equals P2 V2. The way that you read this is the initial pressure times the initial volume is equal to the final pressure times the final volume. Now, constants are not included in equations like this because they don't change from the initial side to the final side. But we will include constants here. The constants, in terms of all the possible variables / constants for gases, are going to be N and T. The reason that you don't see N, which is number of moles, and T, which is temperature in Kelvin, the reason you don't see it in the equation is because it doesn't change. They're constant. We are only concerned about variables for these simple gas laws. The relationship between pressure and volume is considered an inverse relationship. Inverse in that the pressure is directly proportional to the inverse of volume. But that sounds a little clunky. So what we're basically saying with this symbol here is that pressure is proportional to the inverse of volume, or you can just say pressure and volume are inversely proportional. That's why volume is in the denominator. For the graph, we're only going to plot the variables. We have pressure and volume on these axes. And when we talk about an inverse relationship, that basically means that when one is low, the other is high. So at low volume, we have a high pressure. At a high volume, we have a low pressure. And we would connect these points in a curve like this, and that shows us an inverse relationship. The next one is Charles's law. Charles's law is the relationship between volume and temperature. So the equation is V1 over T1 is equal to V2 over T2. So we're looking at what variables are not there. So these are the variables that we tend to deal with for gases: pressure, volume, moles, and temperature. We have volume and temperature changing this time. So what's not there in the equation? The constants are going to be N, because we're not changing the amount of gas from the beginning to the end, or the initial to the final. And notice how P is not in the equation, so it's also a constant. This relationship is considered a direct relationship. And that means that when one is high, the other is high, or when one is low, the other is low. The way that you read this is volume is directly proportional to temperature. Just make sure and remember that temperature is in Kelvin, not Celsius, not Fahrenheit. Here's what it looks like as a graph. We have volume and we have temperature. When temperature is low and volume is low, we're going to have a point in the lower left of the first quadrant. But when temperature is high, volume will be high. That's what's meant by a direct relationship. So you could connect the points like this for the plot for Charles's law. Another one is Gay-Lussac's law. Sometimes this isn't included, and it also has another name because there's like a lot of stuff in history is multiple people discovering things at the same time or slightly different times on different continents. But the equation for Gay-Lussac's law is P1 over T1 is equal to P2 over T2. The way that you read it is the initial pressure divided by the initial temperature is equal to the final pressure divided by the final temperature. As we can see from this equation, there are two variables, pressure and temperature. That means that N, number of moles of gas, and V, the volume, are constants, so they're not in the equation. This relationship has the same structure, these variables have the same structure in terms of the equation as Charles's law, which means that this is also a direct proportion or directly proportional relationship. The way that we would write that relationship between P and T is a similar way as Charles's law. We have this P, this directly proportional to symbol, and then we have T. We could plot this with P and T on these axes, and it's going to take a similar structure as Charles's law. We have a low temperature and low pressure. We have a high temperature and a high pressure. We could connect them that way. And then lastly, we've got Avogadro's law. Avogadro's law is the relationship between volume and number of moles of gas. So we would set it up like this, another way that you could write it, where the left is the initial and the right is the final. This shows us that the variables are volume and number of moles of gas. But notice how temperature and pressure are considered to be constants, so they're not in the equation. This is also a directly proportional relationship between the variables. So we have V, and it's directly proportional to N, or number of moles of gas. We would plot it this way, V and N, where we have a low and low amount and a high and high amount, and we could connect them in a line like that. So those are the 4 basic gas laws. You can actually combine these to create the combined gas law or the ideal gas law. Just keep in mind that the variables we tend to use for gases are pressure, P, volume, V, N, number of moles of gas, and T, the temperature in Kelvin, not Celsius, not Fahrenheit.